Okay, let's look at the area axioms. All right, the first one, A1. For every planar region R with the finite region, so it's a bounded region, there exists area, a real number, non-negative real number called area associated with the region. All right, so that's the existence of the. So this is the existence of the area. Right? A2. If R1 is a subset of R2, right, then area of R1 is less than or equal to the area of R2, right, which makes sense, right? R2 is going to be basically bigger, right? So they call it the dominance postulate. So dominance. All right. Then if you A3, if you look at the area of the intersection of two regions, which happens to be 0, then the area of the union is simply the sum of the area of R1 and the area of R2, right? So this is just additivity. Makes sense, right? Because common region has area 0, so you can simply find the area of each one and add them up. Alright, so let's look at the A4. If you have a two congruent region, then areas are the same, right? Which makes sense, right? So this is the congruence. Alright. And A5, U is a unit square, which means that the 1 unit by 1 unit, a square, then area is equal to 1, right? So this is the unit measure, right? And the last one is called Cavalieri's principle. It says this. So if you look at the cross-sectional length, so if you cut these two regions by a whole bunch of parallel lines, let's say you have a parallel line here, let's say right here, and if you look at those length, this length is exactly the same length as this guy, and let's say you cut it at the different place. You can see that right, these two guys have the same length. So let's assume that no matter where you cut by these whole bunch of parallel lines, these two guys have the same cross-sectional length, right? If that's the case, area of R1 is equal to area of R2, right? So it's basically, if you can, keeping the same length, you can kind of slice things over and still maintain the same area, right? So that's called the Cavalieri's principle, right? So those are the 6 area axioms, and that's it. I hope that this was clear.